All right, hello grade 11s, how are you? I hope that you've done what I've requested, that you've revised the previous lessons and functions, because I won't have time to come back to them. I'm just going to continue now. Now we're busy with lesson 5, the parabola, and now we're going to look at a full equation, y equals to ax squared plus bx plus c. Now what does this mean? This means that the graph is going to shift now, up and down, left and right. So there will be a vertical shift and there will be a horizontal shift. So the entire graph is going to move now. So, of course, this equation can also be written in this form. We spoke about it previously. We call it completing the square. And so both will work. Let's look at our first example. Example 8. Determine the turning points of this graph. Where will this graph, with that smiling and sad face, where will it turn? First of all, I see a is positive, ax squared. So therefore, you remember with positive gradient, you'll have a minimum turning point. So what is that lowest point? Well, what you can do is you take your equation, you write down the first two terms, then this term comes from what we call completing the square. And the formula is b over 2 all squared. B over 2. B is 4. So 4 over 2 gives you 2. And 2 squared gives you this negative 2 squared. You add it and you subtract it in order to balance your equation. Then you separate. So those three there, if you factorize, will give you the first bracket. And those two together will give you minus 1. And then you know from the previous lessons that minus 2, right, is your P value and minus 1 is your Q value, right? So clear, guys. If I go back to the formula, there you are. The P value is the minus 2 and the Q value is the minus 1. So P and Q is the turning point. And of course, P is always with the opposite sign. There is a minus 2 there. It will be a plus 2 here. And the Q remains like that. And there's your turning point. 2 and minus 1. There is, however, a shortcut to determine the turning point. So there is a formula we can use. And the formula is like this. For the x value, and for that to get that 2, it is minus b over 2a. Minus b over 2a. So let's see how do we do it. Right? So minus b, put the minus outside, and b is a minus 4, and a is 1. So you get a 2. Then you take this 2 and substitute into the original equation to get the y value. And there's your turning point. 2 and negative 1. Right. So where does this formula come from? Right? It comes from the quadratic formula. Remember, we've done this in term 1. The quadratic formula, if I split the 2, it looks like that. If I do the opposite of LCM, then it looks like that. And there you can see it. Minus b over 2a. Right. If you look at example 9, if you have to sketch this graph, right? Y equals to, or the f is 3x squared plus 6x minus 9. First of all, the y-intercept is minus 9. How do we know? We just make x 0. So turning point, you can use this formula now. B or minus b over 2a. B is 6, a is 3. And you get a minus 1. Put a minus 1 into the equation and you get minus 12. So there you got your turning point. So you got your y-intercept, you got your turning point, and to get your x-intercepts, you need to make the f of x 0. If you make it 0, factorize, and you get x minus 3 and 1. So now I got my y-intercept, I got my turning point, and I got my x-intercept. So now I can sketch my graph. And there you are. So there's the turning point, and we know it's a smiling face. So it goes down, y-intercept is minus 9, that is the turning point. The x is minus 3 and 1. And there you are. Not so bad, people. Not so difficult. Right. In my next video, we will discuss this form. So the end of this video for now.